Right. So the error term would be the gap between these two. It would be so probably you can look at that error term as the individual specific part. You can look at that error term as the individual specific part, and individual specific part cannot be modeled because it's something which you pick up randomly. Because you picked up that individual randomly from the population. Right? You are not using any specific criteria to choose that individual. The criteria already been chosen in collecting the set of individuals. St. Bernards who are 5 years old have all been collected. So the criteria chosen is given with a sample. Now out of which if you pick up any one particular St. Bernard, then there will be an individual little characteristic which will be captured in the term EI. Right? So that's how really the model goes. So you must look at yi is equal to alpha plus say beta 1 xi plus beta 2 zi plus EIS. There are some common characteristics xi and zi, and there is an average of the weights of St. Bernards depending upon the particular x and particular z. And for any particular individual in St. Bernard, then there is his own individuality. Right? So this particular, so we can also sometimes look at it as individual level heterogeneity. That's something that we get a very important term later on. So what we are saying is EI captures what we can think of as an individual level heterogeneity. Like for example, if you're looking at say price to earning ratios of companies. So the PE ratio of a particular company is your XY variable, and then there are several balance sheet variables there. Right? So alpha plus beta 1 x1 plus beta 2 x2 plus beta n xn. Right? Say x1i, x2i, xni and ei. Sure? Right? So what are we saying? The particular price earnings ratio for this company depends upon, so you are looking at companies which are specific, so there is a certain profit after tax for this company, right? There is a certain, so if you take all companies with the same balance sheet variables and if you average the price earnings ratio, right? Okay? So basically this company has this particular price to earnings ratio because it has certain balance sheet variables. And then there is something which is individually specific to this company, right? There is something individual. So if you take two companies having the same balance sheet variables, they not have the same price to earnings ratios. Let's say there is something which is individual specific to the company. So the best way to look at EI is to think of it as individual level heterogeneity, right? So we say that if you look at any individual's characteristic, you're modeling any individual's characteristic, some of it comes from the fact that this individual belongs to a particular group and there is an average behavior of that group which this individual inherits. But because this individual is an individual, he differs from the group, and therefore you add an EI which is an individual level heterogeneity. Right? Sure? Okay, so that's how that EI term works. Okay. Now, so why the OA? So you see there is this whole approach called curve fitting in statistics, okay? And which I am not a great votary of, but because historically that's what has been done. Because all this regression, a lot of it derived from astronomy. You know, there is a very interesting book called History of Statistics by a man called Stigler, whose father was a Nobel laureate in economics. So this book is also good to read. So there is a lot of so basically the early history of the regression model, etc. is definitely worth reading. And it had to do with fitting curves to some data. So basically suppose you have y and x. And suppose there are these x data points. Right? You have to fit a curve to these data points. You have to describe these data points by a line. Right? You have to describe these data points by a line. So suppose you put a line like this. Okay. Now, so this is, so for the value of x1, this is the value of y which is given by the line, and this is the value of that particular actual value of y, and there is a gap between the actual value of y and the line. Right? Okay. So what would be an ideal line?
Straight line.
passing through all the points would be a problematic thing. Because I can actually, get such a curved polynomial that passes through all these points. That is easy to do.
So which has the minimum distance from all the
Okay, which has the minimum distance from all the points. That's a beautiful point, right? So what's the distance of E1 from this line? Y1 minus alpha plus beta x1 is the distance of E1 from this line. This is alpha plus beta x1, this is E1. By distance, remember we decided that we are going to square distances.
mean square.
Yeah, अपन square करने वाले हैं उसको. तो इसको मैं square करता हूँ, इसको भी square करता हूँ. Yeah? Sure? The sum of all these distances will be E1 square plus E2 square plus E3 square. So the point will be, and now I don't need this diagram anymore, I will get summation EI square is summation YI minus alpha minus beta xi square. The point is, I have to choose alpha and beta to make this distance as small as possible. I have to choose alpha and beta to make this distance as small as possible. Right, so I write. So how do I do this? Now आपको calculus वगैरह मालूम है ना? अब शुरू में तो मालूम अपन भूल गए थे. तो क्या करूँ? इसको मुझको अल्फा से डिफरेंशिएट करना पड़ेगा और बीटा से डिफरेंशिएट करना पड़ेगा. So if I differentiate this, now by alpha, what will I get? 2 will come in the front. अंदर -1 रहेगा. Use the chain rule, ना? Right? -2 summation yi minus alpha minus beta xi is equal to 0. Right? Sure? Which you will realize, so -2 cannot be 0, so this has to be 0. Right? So if I open this out, I get minus yi n alpha minus beta summation xi is equal to 0. If I open this out, because alpha, I add yi n times. Alpha being added n times, it becomes n alpha. Beta gets out common. Beta summation xi. Right? Okay? And you remember that this is also summation ei is equal to 0. That's going to be something more productive. Right? What I'm now going to tell you is only useful for historical reasons. ये OLS क्यों बोलते हैं इसको इसके लिए है, but that is now all fortunately gone, thrown out of the window because we have better ways of understanding things, right?
So why not n beta?
Because beta common है ना. So what is this? This is going to be beta x1 plus beta x2 plus beta x3 ऐसे आएगा ना? Which is what? Beta x1 plus x2 plus x3 ना?
The summation beta xi.
Yeah, but beta is a constant number. So it will be beta into x1 plus beta into x2 plus beta into x3 so on. Beta will come out common. So x1 plus x2 plus x3 and so on. Right? Okay. Now similarly, summation ei square by gamma beta. Right? What's that going to be? Please remember that this summation ei is equal to 0 also. Y minus alpha minus beta xi is equal to summation ei. Y minus alpha minus beta xi is ei. So summation y minus alpha minus beta xi is equal to 0 is nothing but summation ei is equal to 0. Right? And please remember, that's going to be the more modern kind of an approach. So we are going to, if I take gamma ei square by gamma beta, क्या मिलेगा? 2 will come out in the front, minus will also come out, x बचेगा ना इधर. So I'll get -2 summation xi yi minus alpha minus beta xi is equal to 0. Right? Because first I have to take the derivative of what is outside, that is -2, 2 really, and what is inside is minus xi. Minus xi का minus में बाहर निकाल देता हूँ. Right? Okay. So this means summation xi yi minus alpha minus beta xi is equal to 0. Sure? This is what? Summation xi into ei is equal to 0. Right? Okay? And this also means summation xi yi minus alpha summation xi minus beta summation xi square is equal to 0. Right? Sure? Now with particular data values of x and y, you'll always know what is summation yi. You'll know the value of n. You'll know the value of xi. So suppose this is say 100 minus 20 alpha minus beta 75, right, is equal to 0. So I've got one equation in two unknowns. And similarly, this will give me another equation in two unknowns. So, but 10th standard में वो solve करते थे ना, simultaneous equations. Do you remember?
Yeah.
Me and my brother, some of me and my age and my brother's age is so much, and this 5 years later this will happen and all that, right? Okay. I used to find that the most ridiculous because I don't know, they teach math so badly, in schools. And 7th standard they ask you to do some compound interest, and if Ahmad will loan so much money to Abdul after how many months he will get how much. I used to find that was completely, I think 7th standard kids are interested in what happens when you lend money to other people and all that. Okay, but sure. So you got two equations in two unknowns, and if you solve these two equations in two unknowns, basically you will get the same formula that we get. Right? So therefore, this is called the method of least squares. Yeah, why is it called the method of least squares? We are minimizing the sum of squares. But this is a brute method. I don't like it too much because you got some data, you are fitting some curve in it. It doesn't have an intuitive meaning to it. Right? Whereas you do what we did previously, that conditioning of y given xi is alpha plus beta xi. The first part is the average weight of all St. Bernards. The remaining part is Marty's individuality. So EI is individual level heterogeneity. So beta is covariance yx upon the variance of x. You get the same formula, but you get it in a more intuitive fashion. And also remember, but what I'd like you to remember is, we have got two equations here, summation EI is equal to 0, and we got summation xi EI is equal to 0. Right? Summation EI is equal to 0. Summation xi EI is equal to 0. Both these conditions are required to find alpha and beta. You only need two equations in two unknowns. So they are called identifying conditions. Without those two equations, I can't estimate alpha and beta independently. If I tell you that the sum of my age and my brother's age is 55, and if I tell you that my brother is 30, then you can say my age is 25. But you can't independently find out my age and my brother's age without having the second equation. Right? So similarly, if I don't have one of those equations, I will not be able to solve for two unknowns. And therefore, I will not be able to identify alpha and beta separately. So I would like to call these the identifying restrictions. Summation xi EI is equal to 0. Okay. Now can you tell me one thing? There we assume that covariance x and e is equal to 0. There we assume that covariance x and e is equal to 0. Right? And you ask me whether there is a mathematical way of proving it. But now I will argue that here you can actually prove that covariance xe is summation xi EI. Summation xi EI is actually covariance of x and e. Can you prove it to me? Covariance of xi EI is nothing but summation xi EI. A very, very important identity. Very important bit of information. Can you? So what will be the covariance of xi EI? अपना standard formula लिखो. लिखो अपना standard formula. Covariance of xi EI क्या है? Summation xi minus x bar into EI minus e bar upon n. At the moment n को भूल जाओ. Okay, just think of n being equal to 1. कोई फर्क नहीं पड़ता ना, n कितना है किसने बोला नहीं, वो n, right? Okay, so n को निकाल देंगे. तो summation xi minus x bar into ei minus e bar को अगर ब्रैकेट खोलेंगे तो क्या मिलेगा? Summation xi minus x bar into ei, right? Minus summation xi minus x bar into e bar, right? मिला? Summation xi minus x bar into ei minus summation xi minus x bar into e bar. E bar is a constant, so e bar second bracket के बाहर आएगा. In the second bracket, can you bring out something outside constant?
Yeah.
Summation xi minus x bar into e bar is what? Summation xi minus x bar into e bar. E bar is constant, e bar बाहर आएगा ना? So e bar summation xi minus x bar आएगा ना? अभी e bar is what? E bar, what is the value of e bar? 0. Why is the value of e bar 0?
Some of deviation.
No, because what is e bar? What is the formula for e bar?
Summation
Summation ei upon n. Summation ei equal to 0 अपन इधर भी बोला है ना? Summation ei is equal to 0 we have said here, no? Right? So therefore summation ei is 0 तो e bar भी 0. तो e bar भी 0 हो तो आपके वो इक्वेशन में क्या बचा है? Summation xi minus x bar into ei. Right? अभी इसको फिर खोलिएगा. So what do you get? Summation xi ei minus x bar summation ei. वो भी 0 हो गया. Right? xi minus x bar into ei को खोलेंगे तो summation xi ei minus x bar summation ei मिलेगा, है ना? Summation ei क्या है? 0 है. So summation xi ei बचा सिर्फ. Now when I say summation xi ei is equal to 0, I am effectively saying that covariance xi is equal to 0. Right? I am effectively saying that covariance xi is equal to 0.
Sorry, so we got summation ei within brackets xi minus x bar. Right?
No. What? Yeah, you're right.
Yeah.
So
And
what?
then-
Yeah. So you will get summation ei xi minus x bar. This is summation ei xi minus x bar summation ei. So this part will be 0.
Yeah.
So if I say summation ei xi or summation xi ei, right? Let's write it as summation xi ei because this is going to be useful to us in a later context, right? So summation xi ei is equal to 0, setting the covariance of xi to be 0.
Summation xi ei equal to 0.
Which means that the covariance of xi is equal to 0. Because summation xi is nothing but the covariance of xi. Covariance of xi अपन ने दिखा है summation xi दिया है ना after all the brackets open up. Yeah? Sure? After all the brackets open out, covariance of xi ei is nothing but summation xi ei. Right? So setting the covariance of xi is equal to 0 is nothing but setting summation xi ei is equal to 0. So here we are deriving alpha hat and beta hat by setting summation xi is equal to 0. There we are deriving beta hat and alpha hat by saying that covariance x is equal to 0. So we are using the same identifying conditions. And so we will identify the same parameters. Because we are using the same identifying conditions. Yeah? Right? But we are using two different methods. The curve fitting method starts with getting the line of best fit to whatever data you see. Whereas the covariance approach starts with saying that I can break y into various components. And then with good reason I can tell you what alpha and beta will be. Right? So there's a difference in the approach to the two things, but they basically mean the same thing. Right? They basically mean the same thing. Okay, now remember, summation ei is equal to 0 and summation xi ei is equal to 0 very, very important. Okay, because actually you see, now I can use this to also, so I can tell you how you can also solve a model, a regression model which has not just one explanatory variable, more than one explanatory variables. How you can solve for a regression model which is not just one explanatory variable, but more than one explanatory variable. How to generalize this model. So suppose yi depends upon x2, x1, xz, whatever. How to find the values of those coefficients? Right? Is what we are going to generalize this. So first suppose I have y. Okay, which is saying I got n values of y. Okay? So these are all my n values. I put them in a column matrix. Yeah. What is the dimension of this column matrix? N cross 1. Right? My model is what? Yi is equal to alpha So I call this beta 1. This is my model, right? Y is equal to alpha plus beta 1 xi plus ei. Right? This is my model. Instead of beta, I am just writing beta 1.
Alpha, also we can write alpha.
Okay. If you want, we can write that. Yeah? Okay. So this now, I can write, if I write this 111 n times, x1, x2, x3, x4 up to xn, if I call this whole matrix an X matrix, its dimensions now are n rows, 2 columns. Right? If I multiply this with alpha 1, beta 1, okay, and if I call this beta, okay, plus say E1, E2, E3, En, and this whole thing I call E. So if you multiply the first, what will you get? You get Y1 is equal to alpha 1 plus beta 1 x1 plus E1. You will get Y2 is equal to alpha plus beta 1 x2 plus E2. So on, you will finally get Yn is equal to alpha 1 plus beta 1 xn plus En. So this equation will be reproduced for all values. Right? So this is a shorthand way of writing this. So I can write this system as, in a matrix form as y is equal to x beta plus e, where y is an n cross 1 matrix, x is an n cross 2 matrix, beta is a 2 cross 1 matrix, plus e is a n cross 1 matrix. So things are all adding up properly, no? N cross 2 into 2 cross 1 is n cross 1. N cross 1 plus n cross 1 is n cross 1. Right? Okay? Sure? So I am getting it properly. Now here remember, I want to impose the identifying conditions x is, I want to now get summation ei is equal to 0 and summation xi ei is equal to 0. Okay, how will I get them? I will get them as follows. Think of the matrix X transpose. Yeah? If I do X transpose, what will I get? 1, 1, 1, 1, 1. You know what is X transpose, no? Like that ship which has been lying on its side somewhere, you put the matrix, make the matrix lie on its side. Just push this like this. Right? So the matrix falls down. Think of it as falling down, and the first row will become like this, and the second row will become like this. Right? Okay, 1, 1, 1. x1, x2, x3 up to xn. Okay. अभी मैं उसको e1, e2, e3, en से मल्टीप्लाई करता हूँ. So the first equation. First क्या होगा? First row, first column क्या होगा? Summation ei. So summation ei, I know I have to set to 0. What is second row, second column? Summation xi ei has to also be equal to set to 0. Which means that what is this matrix? This matrix is X transpose E. So I have to set the X transpose E matrix to be 0. Right? I have to set the X transpose E matrix to be 0. Right? But what is X transpose E? Y is equal to X beta plus E. So what is E? E now is Y minus X beta, because Y is equal to X beta plus E. So E is Y minus X beta. Sure? Okay. So what is X transpose? E is equal to X transpose Y minus X beta. Right? Which is equal to X dash Y minus X dash X beta. Huh? Right? Which is set to 0. So I get the equation following from this. So this equation essentially means that X dash Y minus x dash x beta is equal to 0, or this equation essentially means that x dash y is equal to x dash x beta, or this equation essentially means that x dash x inverse x dash y is equal to beta. Because I have to pre-multiply both sides by x dash x inverse to get rid of this beta. And if you multiply, pre-multiply here and pre-multiply here. So x dash x inverse x dash y is equal to beta will be the general formulation. So अगर आपके रिग्रेशन मॉडल में एक z वेरिएबल है, आप उसको बताइए अभी कि सपोज योर रिग्रेशन इज मार्टीज वेट इज अल्फा प्लस बीटा 1, राइट? The fact that it's a Saint Bernard plus beta 2, a particular weight Wi plus being Marty, right? Plus being Marty. You have to tell me how to estimate alpha, beta 1, beta 2. क्या करेंगे? ये स्ट्रक्चर कैसे बदलेगा?
Sorry, could you?
Yeah, so now I want you to tell me how you will modify the structure to estimate alpha, beta 1 and beta 2. Maybe you might think more clearly if you have a cup of tea. So let's go and have a cup of tea and then start thinking more clearly.